In this video, I'll explain both distance and displacement. So, distance is the total length traveled by someone or an object. So, let's say that's me, and I want to reach my college, which is 100 meters away. The distance I traveled from my initial position to the college is called distance. And this distance is equal to 100 meters. So let's take some examples. If you travel from your house to your friend's house and have breakfast with your friend, then went to school together, what is the total distance you traveled? So he wants the total distance I traveled from my house to my friend's house and then to school. The total distance between my house and my friend's house is equal to 50 meters. So let's write down 50. Then the total distance between my friend's house and the school is equal to 80 meters. So we will add 80. 50 plus 80 is equal to 130 meters. And this will be the total distance I traveled. Let's take another example. After school, you and your friend went back to your house to play PS5. Then your friend went back to his house for dinner. What is the total distance your friend traveled? So here wants the total distance my friend traveled. So we both started from school and went to my house. And the total distance between the school and my house is equal to 80 plus 50. And then from my house to my friend's house will be the distance my friend traveled next after we played PS5. So this distance is equal to 50, so we'll add 50. Adding these three components, we'll get the total distance my friend traveled in this particular trip. 80 plus 50 is equal to 130, plus 50 equal to 180 meters. And that would be the total distance my friend traveled. Now what about this example? If a spaceship launched from Earth traveled 382,000 kilometers in a straight line to the moon, then the spaceship went back to Earth. What is the total distance the spaceship traveled in this trip? So let's say that the Earth and that the moon, and this is a spaceship. And the distance between the Earth and the moon is 382,000 kilometers, right? Went to moon, and then it went back from moon to Earth in the same straight line. And he's asking about the total distance the spaceship traveled. So first, the spaceship dropped 382,000 kilometers from Earth to moon, and then traveled back 382 kilometers from moon to Earth. So the answer will be 382 plus 382, which is equal to 764,000 kilometers. Now what about this example? If Ali moved from point C to point A, so he moved from C to A, then move from point A to D. So you move from here to D. What is the total distance Ali traveled? So in the first part of the question, Ali moved from C to A, and the distance between C to A is equal to 15 plus 10. So in the first part, he moved 15 plus 10 meters. In the second part, he moved from point A to point D, and the distance between point A and D is equal to 10 plus 15 plus 20. And the total distance he traveled in this trip will be the sum of all these values. 15 plus 10 is equal to 25, and 10 plus 15 plus 20 is equal to 45. 25 plus 45 is equal to 70 meters. So the total distance Ali traveled is equal to 70 meters. Now, after we understand it, what is the distance and we solved some problems on this topic, let's take the displacement. The displacement is a change of position. So first, you need to understand that there's final position, which is denoted as xf, and initial position, which is denoted as xi, and the displacement is denoted as delta x. And delta x is equal to the final position xf minus the initial position xi. Alright? So let's say you travel from your house to the gym, and then to a restaurant. Right? So the distance between you and the gym is equal to 20 meters, for example. And the distance between the restaurant and your house is 10 meters. And the initial position, which is xi, is right here at your house. It's the position where you started the trip. And the final position is xf, where you finished the trip, which is a restaurant. So xf is at the restaurant. So in order to solve this question, you have to draw a one-dimensional line where your house is equal to a position of 0 and the gym is equal to 20 and the restaurant is equal to negative 10. The displacement, which is delta x, will equal to xf, which is at the restaurant, minus xi, which is 0 at your house. xf is equal to negative 10 and xi is equal to 0. So the final answer will be negative 10. What if xf was at the gym? What would be your new displacement if you went from your house to the gym? In this case, xf will equal to 20 and xi will remain the same. So the final displacement will equal to 20 meters. So as you can see, the displacement could be a negative number or a positive number. And that's because displacement is a vector. While distance is always positive because it is a scalar. So it can never be a negative value. Now let's take this example. If you travel from point A to point B what will be your displacement? So point A is the initial position, which is xi, and point B is the final position, which is xf. And we know that delta x, which is the displacement, is equal to xf minus xi. xf is equal to 10. If we draw a line graph where xi is equal to 0 and xf is equal to 10, which is the distance between these 2 points, then xf will equal to 10 and xi will equal to 0. So the final displacement is equal to 10 meters. What about this example? If you travel from point D, which is here, to point A, then from point A to point E, so I first travel from D to A, and then from A to E. What is your displacement? So first we'll draw a line graph where D is equal to 0 and E is equal to half the distance, as you can see, half the distance of this zoo. So half of 20 is equal to 10. So from D to E, there's 10 meters. And from E to A, there's 10 meters. Now, we started from D, so D will be our xi. And we ended at E, which is 10 meters away from D. So E will be our xf. Sorry, that's 20 meters. This will be 20 meters. Now, delta x is equal to xf minus xi. xf is equal to 10 and xi is equal to 0. So in this case, the total displacement is equal to 10. Now let's solve some distance and displacement questions. If Alex travels 30 meters east, then 50 meters north, what will be Alex's distance and displacement? So Alex traveled first 30 meters to the east, and then, let me redraw that. He travels 30 meters to the east, and then 50 meters north. 30 meters and this 50 meters. What will be Alex's distance traveled and displacement? So first, let's guess the distance. Distance is the total length traveled. Total length. So in this case, we will add 30 and 50. So distance is equal to 30 plus 50. So the distance will equal to 80 meters. Now, what about displacement? Displacement is equal to xf minus xi. xi is this point here, and xf is the point where he finished his trip. So, in order to know the displacement, we should connect a straight line between the final position xf and the initial position xi. And as you can see, we have drawn a right triangle. So in order to know the length of this straight line, we should use the Pythagorean theorem, which says that c to the power of 2 is equal to a to the power of 2 plus b to the power of 2, where c is a straight line, a is equal to 30, and b is equal to 50. Let me clear up some space. So solving for c, c will equal to root a to the power of 2 plus b to the power of 2. Substituting the values, we'll get a c equal to root 30 to the power of 2 plus 50 to the power of 2 will be equal to 58.3. And that should be our displacement. Let's take another example. If you travel 20 meters to the north and 50 meters to the east, then travel 10 more meters to the north, what will be the difference between your distance and your displacement? So first we travel 20 meters to the north, and then 50 meters to the east, and then another 10 meters to the north. What will be the difference between the distance and the displacement? So distance will equal the sum of all these values. So distance will equal to 20 plus 50 plus 10, which will be 70 meters. So distance is equal to 70 meters. Now, what about displacement? Displacement equal to xf minus xi. Xi starts here, and xf, which is there. And in order to know the displacement, we should connect a straight line from xi to xf. So let me redraw this. We'll draw a straight line from xi to xf. As you can see, we can reconstruct this shape to be a right triangle to apply the Pythagorean theorem, right? Where this part, which is a, is equal to 50, and this one, b, is equal to the sum of 10 and 20, which will be 30. So applying the Pythagorean theorem, which is c equal to root a to the power of 2 plus b to the power of 2, we'll have c equal to root 30 to the power of 2 plus 50 to the power of 2, which will equal to 58.3. So the difference between the distance and the displacement is equal to 70, which is the value of the distance, minus 58.3, which is the value of the displacement. 70 minus 58.3 is equal to 11.7 meters, and that will be the answer. Now, what about this question? Sarah traveled from point A to point B on a circular path with a radius of 5 meters. What is her total distance and displacement? So, in order to know the total distance, we need to get the length of this arc over here. And as you can see, the angle at which this arc is formed with is a 90-degree angle. And a 90 degrees angle of a circle is equal to 1 over 4, because the total angle of the circle is equal to 360. And 90 over 360 is equal to 1 over 4. So that this arc is equal to 1 over 4 of the total circumference of the circle. The circumference of the circle is equal to 2 by r. And we already know that we have a radius of 5 meters. So we will substitute the value of r by 5 and we'll multiply this function by 1 over 4. So we'll have a 1 over 4 multiply 2 multiply 5 multiply by. So the final answer will be 1 over 4 multiply 10 by, which is equal to 2.5 pi. And that will be the distance. So the distance is equal to 2.5 pi. Now, what about the displacement? Let me clear up some space first. In order to know the displacement, we have to draw a straight line from the initial point to the final point. So, drawing a straight line from point A to B, we will have a right triangle, as you can see. So C will be the line between A and B, and A will be equal to R and B will equal R. Applying the rule of the Pythagorean theorem, C is equal to B to the power of 2 plus A to the power of 2, where both B and A are equal to 5 meters, because they both equal to the radius. So C will equal to root 5 to the power of 2 plus 5 to the power of 2. So the answer will be 5 root 2. And that will be our displacement. So the displacement is equal to 5 root 2.